Hello and welcome to another video of mine, and in this video I'll show you how to plot a dry unit weight against moisture content graph in Excel. So over here I've already taken some example data from Braja M. Das and Khaled Sobhan's book on geotechnics. So I've already converted the specimen mass in grams to kilograms, and now we all just need to calculate these three columns here, and then we can plot our graph. So to start with moist unit weight, all you need to do is follow this equation here. Calculate the weight of the specimen and divide it by the volume of that specimen. Calculate weight, just type in equal mass in kilograms multiplied by G. And since we are using kilonewtons, so we need to divide this by 1000. Then we need to divide this weight in kilonewtons by the volume, which is this here. And do use absolute cell referencing if you want to drag this equation down and copy it. And this volume here represents the volume of your Proctor test mole. So do bear in mind that you should check the volume of your mole before you assume it is 944. It could be slightly different depending on the specifications for your Proctor test. So now that we've calculated our moist unit weight here, we can just drag it down and calculated all the moist unit weights for each of the different moisture contents. Now to calculate dry unit weight, you just need to follow this equation over here. So just type in equal sign 18.456 divided by 1 plus 5% divided by 100, and just drag this down. So now the zero air void line is basically the line in which the maximum dry unit weight would lie on if and only if there are no air voids in the soil, and that can only happen if the soil is fully saturated. So in order to calculate the zero air void line, we can just use the equation on the very right over here. The equal sign unit weight of water, which is 9.81 kilonewtons per meter cube, and divided by 5% divided by 100, add by 1 over specific gravity, and key in your absolute referencing and drag this down. So now we can plot our graph. So we can just go to insert, scatter plot, choose this one here with the smooth lines and markers. So I'll move this down and select the data. So for our first series, it will be named as the dry unit weight against moisture content. The X values would be your moisture content, your Y values would be your dry unit weight over here. Then the next line would be your zero air void line, so just name it as such. Again, the x-axis would be occupied by the moisture content, and your y-axis should be occupied by this column here, by the data in this column. So click on OK and OK. And let's add some axis titles and chart title and a legend. So the chart title, I'll just name it as dry unit weight against moisture content graph. On the x-axis, I'll name this as moisture content in percent. On the y-axis, I'll just call this dry unit weight in kilonewtons per meter cube. And I'll make this horizontal, and we can go and format this y-axis so that it'll start at 15. And now to find the optimum moisture content and the maximum dry unit weight, all you need to do is just draw in some lines. So go to insert, and under the shapes button, just choose the line tool, and let's draw a line from roughly here, the y-axis, and let's use a black color so it doesn't blend in with the blue. And let's draw another line down to the x-axis, and there you go. So our optimum moisture content is somewhere close to 10%, about 9.9%, and the dry unit weight is approximately 19.1 or 19.2 kilonewtons per meter cube. So that's how you go and plot a dry unit weight against moisture content graph. I hope that you found this quite easy to understand, and I hope that you can actually go and replicate this calculation for whatever coursework or anything else that you need to do. So if you do like this video, give it a thumbs up, and if you want to watch more videos about civil engineering and its related softwares, yeah, do subscribe to my channel. And in the next video, I will show you how to go and create your soil material model and model a geotextile in Plaxis 2D. So until next time, I hope you're safe, and bye.